A Brief History of Atoms by Shad al-Qassas. The great physicist Richard Feynman once said, "I, a universe of atoms, an atom in the universe." The atom is the basic constituent of everything. The universe, stars, the planets, the air, and even the screen in front of you. But have you ever wondered how we developed the basic understanding of the atoms? It is an interesting story that has a long history. It begins in 440 BC by Lev Pikas. He suggested the atomism theory, which suggested that everything is composed entirely of various imperishable, indivisible elements. In 400 BC, the Greek philosopher Democritus called atoms for the first time from the Greek word atomos, which means that cannot be split. But in 340 BC, Aristotle opposed the idea of Democritus, and he suggested that matter is made of four basic elements: fire, air, water, and earth. But in 1803, Dalton adopted Democritus' idea again, and he suggested that everything is made of atoms, which elements has different types of atoms. But unfortunately, he thought that they are invisible. In 1897, and as a result of his cathode ray experiments, Thomson discovered electrons. But unfortunately, he suggested the plum pudding model, which suggests that electrons are scattered throughout a spherical cloud. But in 1900, Planck suggested a revolutionary theory, which stated that energy doesn't come in waves, but in tiny little packets that we call quanta. In 1911, Rutherford discovered the positive charge in nucleus. But he couldn't explain the electrons' movement around the positive nucleus. In 1913, Niels Bohr explained what Rutherford couldn't by suggesting that electrons occupy orbits of fixed sizes and energies, which means that energies are quantized and they have specific energy. But unfortunately, he thought that moving electrons should emit energies until they collapse into the nucleus. And also his model didn't work for heavy atoms. In 1926, Schrödinger suggested that electrons are not moving in fixed paths, but they are moving in waves or clouds. He also suggested that we cannot identify the exact location of electrons. It is all about probability. And finally, in 1932, Chadwick proved the existence of neutral charges with mass inside the nucleus, which we call now neutrons.